Hi, my name's Tom Hoeffel, and this channel is all about helping students learn chemistry. In this video, we're going to be discussing molecular geometry and bond angles. It's intended to be a quick review of a video that I did earlier that goes into great detail as to how these structures are formed. So if you're curious about the how and the why, please watch that other video. But if you just want a quick review, you're in the right place. Like if you want to review this right before a test or a quiz, you're in a great place. So let's get into it. If you have a structure that has two domains, 1, 2, okay, you're going to have a linear molecule and the bond angle is going to be 180 degrees. If you have a structure that has 3 electron domains, 1, 2, 3, the structure is going to be trigonal planar because I'm making this triangle and it's flat like a pancake, so we call it trigonal planar. And it has a bond angle of 120 degrees. If there was a lone pair with your 3 domains, you would get a structure like this. So 2 bonding domains, 1 lone pair. The molecular geometry or the shape of the atoms is going to be bent. And this lone pair squeezes that angle by about 1.5 degrees. So 1.5 degrees less than our original 120 would be an approximate bond angle for bent. If you have 4 domains, 1, 2, 3, 4, you get a structure that looks like this. It's a tetrahedral shape, and the bond angles are 109.5. If you have a lone pair, so 3 bonding and 1 lone pair, your molecular geometry now becomes trigonal pyramidal. Still a triangle, but it's no longer flat like a pancake like this one is. It's flat like a pancake. This one is raised up as a pyramid. So once again, trigonal pyramidal, okay? And the bond angles are squeezed about 1.5 degrees from 109.5. If there were 2 lone pairs, this would be bent, okay? And with 2 lone pairs, 1.5 degrees for each of them, about 3 degrees less than 109.5, so around 106.5 for the bond angle of this bent. If we had 5 domains, we would get this structure, okay? Now it has a triangle as well, so we're back to trigonal, okay? And there's a pyramid coming up and a pyramid coming down, so we call it trigonal bipyramidal. This is the only one that is not perfectly symmetrical, okay? And because it's not perfectly symmetrical, we have positions. These are called axial positions because it spins on the axis, and the other 3 are called equatorial, okay? Because they're kind of like the equator. Like if this was the planet Earth, this is where the equator would be. So axial, and then these 3 would be equatorial. The bond angles, axial to axial, is 180. Equatorial to equatorial would be 120, and then axial to equatorial would be 90. This structure is actually a combination of these 2. Okay, so trigonal bipyramidal, okay, is a combination of trigonal planar and linear kind of put together. Okay, if we have 1 lone pair, they have to come off the equatorial plane. Okay, so this is the shape, and this is what we call seesaw because it looks like a seesaw, or what some people would call a teeter-totter, but the shape is actually seesaw. Bond angles are all less by 1.5 degrees because this lone pair is squeezing everything in. If there were 2 lone pairs, we call it T-shape. If there's 3 lone pairs, we call it linear. And finally, if we have 6 domains, we have this guy over here, which is called octahedral. Now this one is symmetrical, so there's no axial positions because it looks the same this way, as this way, as this way, as this way. So it doesn't matter how we hold it, it is completely symmetrical all around. So there's no axial or equatorial positions here, okay? All the bond angles are 90 degrees for octahedral. If there was 1 lone pair, we would call this square, but it's a pyramid, so we call it square, pyramidal. If there's two lone pairs, We'd still call it square, but now it's flat like a pancake again. Okay, so this is square planar. And I hope all of this helped. Okay, as a quick review before you take a quiz or a test over your molecular geometry as far as the vocabulary names and the bond angles. And if this information was helpful for you and you like this type of content, please like and subscribe. That helps the YouTube algorithm get this information out to more students that are interested in learning chemistry in a straightforward fashion.